In part 3 of the Unit 6 notes, we will be naming for binary ionic compounds. A binary ionic compound contains only two different atoms. It consists of a monatomic cation, monatomic meaning just one type of atom in the cation, and a monatomic anion. We will use the following rules when naming binary ionic compounds. The metal name stays the same, but the nonmetal name changes to an IDE ending. You probably already know this rule from sodium chloride, which is NaCl. So it's made up of a sodium and a chlorine atom. But the INE ending of chlorine changes to IDE. Our second rule is if the metal has more than one potential positive charge, the charge must be written as a Roman numeral after the metal name. This helps us to distinguish between the different variations of that metal. So for example, iron can have more than one potential positive charge. In FeCl3, the charge of the iron is 3. So in the name, we would call this iron 3 chloride. For our third rule, to determine the charge of the metal within the formula, you can cross the subscripts back up diagonally. The value of the superscript will represent the charge. Metals will always have a positive charge, and nonmetals will always have a negative charge. Be aware that the subscripts may have been reduced, which is what has happened in this example here. So if we take our Fe and O, we have subscripts of 1 for each. If we were to cross those 1's back up, it would appear that oxygen would be a -1 and iron would be a +1. But if you look at the periodic table for oxygen, oxygen would always form a -2 charge. That means that this has been reduced at some point. In order to unreduce it, I can turn this back into a -2 by doubling that charge. And I'm allowed to do that as long as I also double the other side. So this iron would have a +2 charge. Here we have a version of the periodic table which is color-coded to show the different families and different types of elements, and it also has charges written in. This will be helpful for when you are trying to determine if an element has more than one charge. For example, in our transition metals section where most of these issues occur, we can see that scandium is always a +3. So we would not have to use a Roman numeral when writing out the name of a scandium compound. But titanium could be a +3 or a +4. So after the titanium, I would need a Roman numeral within the compound name to tell me which one it is. Now on this periodic table, they only give you the most common oxidation states or charges. So there could be instances where maybe an oxidation state that you run into is not actually listed on here. The way that you should use this periodic table is simply to see if there is more than one possibility in the symbol. For our first checkpoint question, we are going to be writing out the name of the compound for each of the following element combinations. We are going to be checking the periodic table to determine if the metal has more than one potential charge. If it does, we need to write the Roman numeral after the metal name. If it doesn't, then that part would not be included. In our first example here, we have calcium with a +2 charge and bromine. The metal name is always going to remain the same. So we have calcium. If we were to look at that colored periodic table, calcium is always a +2 charge. So I don't need to specify that it is calcium with a +2 within my name. So I skip that part. Bromine would become bromide with an IDE ending. So our name for our first compound is calcium bromide. Next up, we have beryllium. Beryllium, the name is going to stay the same, and then we have to determine if we need to specify that it is beryllium with a +2. If we look at the periodic table, beryllium is in the second family of the periodic table. It is always a +2 charge, so we do not have to include the Roman numeral. Sulfur is going to change to sulfide, beryllium sulfide. In our next example, we have iron, and iron is a transition metal which happens to have more than one charge. So I need to specify which iron I am talking about here. It has a positive 2 charge, so I'm going to place a Roman numeral of 2 in the parentheses. The oxygen is going to become oxide. In our next example, we have aluminum. And the aluminum has a positive 3 charge. But aluminum always has a positive 3 charge, so I don't need to include that as part of my name. Selenium is going to become selenide. In our final example, we have platinum. And platinum does have more than one charge if you look it up on the periodic table. So because of that, I need to include the charge inside of my parentheses. This is going to be platinum 4, and the fluorine is going to become fluoride. In this set of checkpoint questions, we are going to be converting from formulas into names. Remember that for each one of the metals which has more than one charge, we are going to need to place a Roman numeral in the parentheses. In our first example, we have Cs, which is cesium. Cesium always is the same charge, a positive 1, so we do not need to include a parentheses. Fluorine would become fluoride. In our second example, we have zinc. Zinc is always a positive 2 charge, so we do not need to include a parentheses here. Nitrogen would become nitride. In our next example, we have K, which is potassium, and potassium is always a positive 1, so no parentheses needed. Sulfur becomes sulfide. In our next example, we have nickel, but nickel has more than one charge, so this time I need to include a set of parentheses. The chlorine is going to become chloride. Now, it is not possible to determine what type of charge this nickel is by simply looking at the periodic table. We need to look at the actual formula that we have. And one of the easiest ways to determine this is by crossing the subscripts back up to the opposing position. So if there are 2 chlorines, that means that nickel was likely a positive 2 charge before. And if there is 1 nickel, that means that chlorine is likely a -1. Once you've completed this step, you should check to see if the negative charge makes sense. If it does, that means that the formula was never reduced. If it doesn't, it means it may have been reduced. In this instance, chlorine is always a -1, so this is good. Nickel would then be the positive 2, and this would be nickel 2 chloride. So we have a 2 in the parentheses. For our next example, we have Ga, which is gallium, and As, which is arsenic. Arsenic would become arsenide. Moving on to this side, we now have Fe, which is iron. Iron has more than one charge, so I need a parentheses. Selenium will become selenide. If we cross our subscripts back up to superscripts, we get a -1 and a +1. So you might think that this is iron 1 selenide. But if you look at the charge of selenium on the periodic table, selenium is always a -2. That means that this was reduced at some point. So if this charge needs to be doubled to get to the charge that it always is, then this charge would have to be doubled as well, a +2. So this would be iron 2 selenide. Al is aluminum, and aluminum is always the same charge, a +3. So we don't have to include that in the parentheses. Bromine would become bromide. Ag is silver. Silver is always the same charge, a +1, so no parentheses needed here. Sulfur becomes sulfide. Next up we have Zr. Zr is zirconium. Zirconium always has the same charge, so we can ignore the parentheses and move on to the nonmetal. Oxygen becomes oxide. In our final example, we have titanium, and titanium has more than one charge, so we're going to need the parentheses. Oxygen, of course, is still going to be oxide. Now, in order to determine the charge of the titanium, we are going to cross the subscripts back up again. If I have 3 oxygens, that means that there is a good chance that titanium was a +3. Since there are 2 titaniums, there's a good chance that oxygen was a -2. The positive and negative is because metals are going to be positive, they're going to give up electrons, and nonmetals are going to be negative, they're going to take them. If you look up the charge for oxygen, oxygen is a -2. So that tells me that this was never reduced, and the charge of the titanium actually is a +3. So we will put a 3 inside of the parentheses. That concludes Unit 6, Notes Part 3. When we come back for Part 4, we will be writing out the formulas for binary ionic compounds.